Very good evening. I think it is visible for each and everyone.
Yeah, it is visible.
Yes, sir. Just we will go through a little bit because we are having at least 30 minutes, half an hour, and in that we will discuss an introductory part of Industry 4.0 actually. And Industry 4.0, how does it evolve and what is its importance and how it constituted, that we will discuss here. Basically, if we see the building block of Industry 4.0, it is integrated by various uh, technology that include cyber security, additive manufacturing, augmented reality, big data analytics, even artificial intelligence, machine learning, autonomous robots, simulation, different types of simulation that are being used nowadays very widely, and horizontal and vertical system integration. These are uh, an industrial internet of things. One is IoT and second one is IIoT, industrial internet of things. So basically today we are just going to discuss an introductory part, and why Industry 4.0 is so important and why we are going to conduct such kind of an important FDP. And we are very happy to uh, get this FTP because in whole India, in the whole nation, only 200 FDP has been granted, and out of that we are one. So just we will discuss an introductory part. Today, just within 20 minutes, we will discuss how industrial evolution takes place and what about the fourth industrial revolution, building blocks of Industry 4.0, and potential benefits, its products, its implication, and impact of Industry 4.0 in modern time. Once upon time, we all have seen such kind of machinery, and these are the passage of time that we will have seen such kind of machinery, and we have reached from here to here, and this is the industrial evolution that we can see here, and that is the Industry 1.0. And it is basically mechanical production machine powered by water and steam. Even steam engine is also one example of Industry 1.0, where machine and mechanism were integrated to take some specific work. And Industry 2.0, that is the beginning of 20th century, in this introducing mass production, line assembly, and mass use of electricity rather than diesel, petrol, or steam, or coal, etc. And Industry 3.0, where electronics and information technology integrated with the mechanical machinery, and that is the progression of autonomous production and little bit industrial automation taken place in the Industry 3.0. And now we are just using industrial revolution, Industry 4.0 nowadays, and at many level we talk Industry 5.0. It may be possible within 1 year or 2 year we will discuss Industry 5.0 rather than 4.0. 4.0 because the complexity, flexibility, each and everything is increasing day by day. Now, just we will discuss a little bit the how phases of industry 1.0 to industry 4.0 has taken place. That is the year in which what happened, starting from the mechanical production, steam engine, to mass production, electricity and assembly line, and even automation started here in industry 2.0, and computer, semiconductor, mainframe computing, personal devices, internet, etc. have taken place. When we discuss industry 4.0, basic introductory part comes from USA or Germany, Japan. These are the country where high level production takes place. So basically, when we discuss industry 4.0, so basically it is a collective term for technology and concepts of value chain organization, and it is based on various technological concept and information technology, internet of things, and various internet services, automation, cyber security, etc. And the old days factory is being going to be converted into smart factories, that is called modular structure. And just in next slide we will discuss some CPS system, that is called cyber physical system, that monitor physical process, create virtual copy of the physical world, and that you can say simulation, the part of simulation, artificial intelligence, and all these happens because of internal and cross organizational services. And we will discuss digital revolution, powerful sensor, machine learning, and energy balance, saving of the energy, artificial intelligence, etc. Similarly, we'll discuss little some idea which we will or you can say social media like thing that we have seen in our just last decades, you can say. And you will be surprised to know that such iPhone, iPad, even 4G, 5G, Android, WhatsApp, Snapchat, Instagram were not present even in 2006. Even YouTube has come in their existence in 2005 itself. But now these are the demand, that you can say public demand, or it was not the necessity of the human being, but the human being is going to be habitual of all these social media or this kind of technology. And nowadays person may not be hungry for food, but they are hungry for data and social media and all such kind of things. When we discuss time to reach 100 and more than 100 million customers, we will see the basic telephone to reach in each and every home, it has taken more than 75 years, while web development and websites and searching the matter like Google Baba, Microsoft, Yahoo, Rediff, it has taken only 7 years. That we can see here, it has taken 10 times lesser times to develop the website and web technology. Similarly, Facebook has reached its 100 million customer only in their first 4 years, while Instagram has taken very less time to reach 100 million customer, that is 2 years. And Pokemon Go, that usually kids like it, and they have reached 100 million customer within 1 month. And we also progressing such kind of things. So now it is time to discuss a little bit CPS system. and it is very much fact that the each and everything is somewhere communicated and attached to information system, whether it is computational part, controlling part, or communication part. Each and every part is being somewhere related with the information. Reason being that for any conclusion you need to take information, data. Data is very important because each and every conclusion or fact will be coming from the information, what kind of data, and one more, the reliability of the data. The data which are available with you, how much it is reliable. Fake data has no existence, but it can give some result and it can mislead the conclusion. So the information should be based on a system. That means the source of information should be uh, very good source, and similarly it should be secure, and it's have the physical viability. It should not be hypothetical. So if we discuss CPS system, it has some unique benefit, that is it is safer and more efficient. It reduces the cost of building and operating the systems, building complex systems, and it enables national or global scale. So the CPS is integrated everywhere nowadays in industry 4.0, either it is software or hardware. Now this is the simple workstation, and it is today's factories where sequenced car manufacturing production line is being shown here, and we all uh, come across all this system. And imagine what today's and tomorrow what changes is taking place. Just it is, you will see here, it is today's situations, and what about tomorrow, that we can see here. Today is not too much flexibility, but tomorrow in the coming days will be fully flexibility, reliability, and it will be integrated manufacturing system. That means information will float over the workstations. These are some of the design principles, and some important design principle, that is the six design principle that we will discuss. That first one is the interoperability. That means the ability of physical system, workpiece, assembly station, products, its quality, human and smart factories connections, communication, internet of things, internet of services will come under interoperability. Another part is virtualization, because each and everything is going to be first virtual, then we see it in, if virtually it is right, then we uh, practice it into physical system. That means the virtual copy of the smart factory which is created by linking sensor data. Another part is decentralization model. That means the ability of cyber CPS system, that is cyber physical system within smart factories to make a decision on their own. And fourth one is real time capability, the capability to collect and analyze the data, whether it is reliable, correct, and provide the insights immediately. That is called real time capability, real time simulation, real time analysis, real time engineering. And fifth one is the service orientation, that offers CPS system integration with human and smart factories via internet of services. And modularity, that means the flexible adaptation of a smart factories for changing the requirement of individual modules or products that may take place. These are building blocks of Industry 4.0 that we have already discussed, and how the Industry 4.0 is impacting the aspects of value chain, how it is increasing the value of the product, and it has various components, and it includes almost all components that we have gone through in our study parts, that is engineering, tool design, simulation, life cycle, digital manufacturing, industrial control system and operation management, enterprise resource planning ERP, global communication infrastructure, supply chain management, industrial communication material, IT infrastructure, public infrastructure, human resources, tools and fixture, sensor actuators. These are the part and parcel of Industry 4.0 that we will see in our physical classes also. These are entire value chain and how the things is going to be digitized and integrated, and this is one example, that is the digital world, and this is the real world. That means you can say there are two kind of approach, one is bottom to top approach and top to bottom approach. In maximum cases we adopt here top to bottom approach, and it includes you can see here, it starts from product design, production planning, production engineering, production, and after production selling and services, and that includes simulation, that is the part 1 to 3, product life cycle management, manufacturing execution system, and totally integrated automation, that is called full automation, and life cycle data driven services. It includes even the feedback of the customer, and these are the potential implication of Industry 4.0. Where do we use it? These are the robotics, mechatronics, robot assisted production, predictive maintenance, additive manufacturing of complicated parts can be designed very easily in with the help of additive manufacturing, and we have already gone through session 1 and session 2. Both were related to additive manufacturing, and also one reason that we have covered additive manufacturing because we have very good machines equipments in our idea lab, in which we can design the product, and fortunately we have purchased too much raw material on that you can design product on 3D printers, that is the part of additive manufacturing, and any kind of complex part that you can design not only on software, but you can just take picture and convert it into the real time product that we will use in our offline classes and during the practical sessions. Similarly, quality control was a very big issue uh, earlier, but now it has become very comfortable because we can check the quality with the help of big data, because data will be available, so artificial intelligence can work very right in right manner. And another part is production line simulation and a smart supply network, including supply chain management, that is the part of supply chain management, and robots working, and how the utilization of robots is increasing all over the world. It is just one pictorial example of Amazon headquarters, how they are using um, to pick and place the uh, their items And even in chemical industries, uh, there was a time when workers were uh, not ready to work in difficult and critical situation, but now robots is being developed to work even in the high temperature, in critical conditions, and even in any kind of chemical gaseous surrounding. So it is, these are the benefits of the robots. And one more example is Siemens. Siemens is one of the leading company that manufacture the controller for any kind of robot. And Siemens is basically uh, developed so many softwares that we will see in our upcoming classes. And he has developed products, he has customized according to the need of end users, and they produce the product within an hour on the basis of demand of the product. As soon as customer call the product, that is the concept of JIT, just in time manufacturing, and they are using on that concept. Similarly, these are the example. Trump is also one big name that are utilizing the smart manufacturing, because it leads to production facility, not only production facility but complicated product, highly delicious product they manufacture. Suppose biomedical product, they are very sensitive and crucial. They design such kind of product uh, fully automatically. Similarly, GE is also a big name that predicts the operating system for the industrial internet of things, is powering digital revolution, analyzing data. These are the big names. Philips, Medtronic, these are the big names. And somehow industry 4.0 is impacting our national and international economy, business, national and global industrial parts. Even it is impacting society, family and individual ones. It also impact economy like growth, productivity, employment, labor substitution, and critical nature of work, customer expectation, data enhanced product, collaborative innovation, new operating models, and national and global society, individual. And what we have seen in 2020 and 2015, that we just imagine where there is a scope that uh, in 2020 we can create something new. There is critical thinking, brainstorming, people management, emotional intelligence, and that all can be um possible with the help of industry 4.0 softwares. So it was the uh, an introductory part of industry 4.0, and I hope you will have seen it. And if anyone is having any kind of query, then we can discuss within 2 to 5 minutes, and after that we will discuss. Yes, please, any audience.
I would just add to this, Jitan sir,
Yes, please, sir.
because in the presentation you just told that in 2006 we were not knowing this, what is iPhone and all that.
Yes,
So in 2006 I was associated with Rolls-Royce at England.
yes,
So at that time they were working on their aircraft engines, which were transmitting real-time data
yes,
uh, from the aircraft flying. The aircraft was flying and the engine what are the engine conditions and what is the altitude flying, what is the temperatures and everything.
Yes,
The real time data was being transferred to रोल्स रॉयस हेडक्वार्टर. तो कोई भी एयरक्राफ्ट उड़ रहा था उसका सारा डेटा रोल्स रॉयस के पास में आ रहा था.
all right.
सो दैट वाज द स्टार्टिंग पॉइंट.
Point
हमको नाम नहीं मालूम था कि वन डे दिस विल बी कॉल्ड एज इंडस्ट्री 4.0.
zero. Yes,
So that was the thing, that the machine were talking to the other machine through the internet, because they had put some chip and sort of SIM card on the flying engine, and that chip was transmitting real-time data. Based on that data, analysis software were analyzing कि अब इस एयरक्राफ्ट में कब प्रॉब्लम आने वाली है या कौन सा सिस्टम ओवरहॉल होने की जरूरत है. So
yes.
that was the starting in the very beginning of 2006. So
That
the name has
yes,
been given later on.
yes, sir. Yes, sir. Definitely, that was a limited use, limited application. But now it is wide
Limited
application.
application, but
Yes,
it
was
was
there.
started way back in
Yeah.
2006.
Yes.
But name was not given that
Yes,
this is the industry 4.0, and
yes.
this 4.0 is not limited to manufacturing only.
Yes.
Like this is for the service industry. Like when you are having data and you can say that your machine is going to be under say overhaul or something, so you
Yes.
are doing servicing part. So that 4. Industry 4.0 also belongs to the service class industry also. I think we can close the session. Nobody has any doubt or something. So we can
Uh,
close the session and we'll meet tomorrow
yes,
if
sir.
somebody has doubt.
If any participants have any kind of doubt, can ask, and I hope each and everyone have filled their feedback form. We have already dropped in the chat box.
So feedbacks form for the first session only or for second session also?
Both sessions are even
Both sessions separate feedback forms.
yes, sir. Once again, I just drop it, and if anyone have not filled, they can fill it.
Yep. So I think we can close. Thank you everybody.